Let's start with Jiralib library system that I use a lot in all of my mods, and I plan to use it in any possible mod in future. Hello everyone, this is Ali Reza. Welcome to the Mentor Code Lab. As you recall, in our main mod, we had lots of errors related to different blocks, actually, like the GUI or the other block systems. And I just noticed that we don't have this register trapdoor, okay, and fence gate. What's the problem there? Ah, this is register fence. I didn't rename it. Oh, well, I don't like these two. Okay, I know what to do. In between the episodes, I will remove my artifact and my cache download files, and I will fix these two and re-upload them. But long story short, we have problems with GUI, we have problems with machines, and the reason is that, as I showed you before in the previous episode, our GUI, the base GUI, is using a class, abstract activatable block. Now, it's not belonging to Fabric API. It doesn't belong to Minecraft itself. This is a class that I will go and develop inside my Jiralib system. The same thing can be said about my machines. So if I open, for example, the block breaker, you see that it's abstract machine block. This is something that will work. We will write it inside the gmachina as the last library that we produce. So keep in mind, we have some problems that we will cover step by step as we go forward from now on. And I highly recommend watching every video from now on very carefully, because we are not talking about basic stuff anymore. Here we are developing our own API, and we will talk about different aspects of Minecraft that we can use. Also, remember that Jiralib has some access wideners. You don't need to care about them. Basically, it will work, and if you want to use Jiralib, you just depend your mod on the library and use my classes. So there is nothing wrong with that. Let's start with our records. Now we will have some records, and these records will be used as different payloads. Each payload can carry some data from the client to the server or reverse. So what we are writing here is dedicated for networking, although we are not talking about networking right now, but what we are providing is actually a record, a piece of code and data that can be serialized and deserialized both on your machine and through network and being sent back and forth between client and server. We want a block pose payload. Now this block pose payload is not a class, it's a record. As the name suggests, all we want to store and have around is a block pose from net Minecraft util math, and we call it pose. Now this implements the custom payload from net Minecraft network packet, and because of that we have to implement some methods, and that is get ID. We have to define an ID to return it. So we say public static final ID from net Minecraft network packet custom payload of type block pose payload. We call it ID equals to new ID of identifier dot of. Now, of course, I could use an identifier helper here, but honestly, I don't care about it. So this is Jiralib, comma, block pose payload, and that is our ID. Now, remember, as I said, this could be using a helper method somewhere, and of course we have it on reference, but take note, libraries don't have any entry point. So if I want to have a reference somewhere, first of all, I have to bind a dependency here for my reference, and I don't want to do that. This library should be standalone. As you see, it's not depending on any other thing, and I don't want to have complex relationships between my libraries, so I can just go with identifier, and I need to make sure that this guy relays the same, because this is my mod ID. If you notice, this is Jiralib. I copy it, I paste it, and that's it. Don't worry, from now on we will copy this payload and keep this thing and only change the path so that everything will work. Now we want a codec. If I hit Alt-Enter, I have this generate codec for type. Keep in mind, this is a plugin called codec for Minecraft, and you see that it adds it on top. I don't like it on top, I want it here. And when I use it, I review it to make sure everything works. So it should be a record codec builder that create. Instance goes into, actually, let's keep it this way, the group, and after the open parenthesis, the T1 should be block pose.codec field of pose for getter, the block pose colon pose, and finally we hit the, there we go, apply for the instance with the function of creating a new block pose payload. After this, I have to create a packet codec, because as I said, if I have a codec, I can serialize and deserialize any block pose payload on the hard drive or in NBTs now, because in the current version NBTs are using codecs font. If I want to send a packet through the network with this payload, I need something else, and that is public static final, a packet codec of type registry byte buff, and of course this one is block pose payload. We call it packet underline codec. This may look confusing at the start, but honestly this is a codec that is dedicatedly made for the network, and instead of calling the record codec builder.create, we have the packet codec dot tuple. And tuple is Java thing, so you can just go and find and look at it. So we have a block pose. Thankfully, block pose has its own packet codec that we can utilize, and we call the block pose payload colon pose as the other side of serialization. And finally, the instantiation of block pose payload colon new. This line tells that we have two pairs of information for you. One should be used when we want to serialize. One is what we serialize, and when we are deserializing, we want to use this method. This information tells the network how to handle this payload. Finally, at the end, here we send back the ID. And that is our block pose payload. Using this class now, we should be able to keep block poses on any item as information as we had before. Because if you look, we have coordinate data payload. That's a little bit more complex compared to this. It will have a dimension name. But that's the whole story. We can store a payload or a data here, a record, on any item as the data, or we register it on NBTs on block entities, or any other place. We can even use the codec and convert it to JSON and write it on the file if you want to. Or alternatively, we can send the data through the network between client and server, and that will become handy when you want to open an interface for any block entity, because then we will send the block pose payload. We will have the block position of any block entity. Let's move forward. The next one is called the Boolean payload. However, instead of writing everything, I will keep control and drag and drop it here, and I will change the name to Boolean payload. Hit enter. Now you see that it asks for a block pose. That's wrong here for sure. We return a Boolean and we call it value. The ID, that's the fun part. You just need to change this block pose to Boolean. And of course, we don't have this codec. We don't have the packet codec like that. But for the codec is actually, instead of block pose codec, we have codec as the class for Mojang serialization. And here we have Boolean as BOOL field of value for the getter of Boolean colon value, and then apply to Boolean payload colon new. Then here we have the Boolean payload packet codec tuple of. Instead of block pose, we have packet codecs with an S dot Boolean, and Boolean payload for value, and finally the colon new. And that's it. Now we have a Boolean payload, so we can send true or false through the network. Now I have something much more complex, and I don't want to handle it right now, but I will add the class name, and this is called configured ingredient. This will become handy when we are writing our recipes, and without understanding recipes, this will become a little bit confusing. I will have a record, and I will put the to-do. I will close the other payloads, but keep that in open. I will finish it before publishing because I have to do that, but I want to explain it in detail in another video. Now, we have something that is close to block pose, and that is coordinates, as I said. So this is coordinate data payload. Why not? And coordinate data payload is asking for a block pose, but at the same time, we want a string called dimension, because we want to make sure we know what is the dimension. And here we say this is coordinate data payload. The codec will have the block pose first, but at the end, before the closing of parentheses, we go for T2, and that is codec dot string dot field of. The field is called dimension. Make sure that you use the same name and you don't have any typos. Dot for getter coordinate data payload dimension, and that's our codec. The packet codec uses the tuple packet codec coordinate pose, but then we have another one, packet codecs with an S dot string, and that is the coordinate data dimension, and finally the dimension. So if I want to break it, I have to break it like this. I think I will break it like this, yeah, because that's codec 1, that's codec 2, and this one is the 2, so like so makes more sense. That's our coordinates. Now the other ones are as simple as Boolean. So this one is for sending in a double payload. The double payload, of course, needs a double as the value. This will be double payload. This one is the double here. This one is the double here. Not degrees, double. And that's it. That's our double payload. Then we have a float payload. Let's call it float payload. This needs a float. And yes, I could use the double, but then we will have precisions and problems with precisions. So this will be a float. This will be a float. And that's it. Then we have yet another complex one. Actually, this is not as complex, but I will write it after finishing everything and in its own video because, it's talking about fluids. We will have a to-do, write the code, close this guy, close this guy. Then we have a hand payload. Now, this one is, I don't know, interesting because it has nothing special, but I think in networks, it can be interesting to know what is the hand that player was using. So this is the hand payload. The codec is not this anymore. For the codec, we say codec dot string, but here we use xmap of a string goes into objects dot require non-null from hand on net Minecraft utils dot value of the string that we have, two parentheses later. For the xmap, now we have hand colon name. After this, we need to set the field. So field of hand, because I forgot this is hand here and we call it hand. So that's the field. And finally, dot for getter, that is hand payload colon hand. And I will break these two to a new line so that we know it's T1. The packet codec is again a tuple. However, instead of a float, we want a string. The from and the to is different now because these will be lambdas. So we have a payload and we want to deserialize the payload. So we will say payload.hand.name. The constructor for the to is hand str. So we have the string and we want to serialize it to a new hand payload. And here we say hand.value of the hand string. And because now we know how to create the payload, now we understand how to basically serialize it. That's our hand payload. Basically now we can send what hand is being used by the player through the network. And then something close to the float, and that is int payload. This is an int, we call it value, and this is integer. Just let me check that it's changed correctly. Now here we need int and int here, and that's it. And this one is integer actually. Yep, okay. So that's that. We have the hand. Okay, we have more complex things. These are related to the recipes again, and this is output item stack. So when you want to output something by your machines, this is what you will use. So write the code. Let's keep that. And sometimes you want to send an item stack on the run. So let's get this guy, but change it to single stack payload. Actually, I will call it item stack payload. Item stack payload asks for item stack, and we call it stack. The ID is item stack payload. The constructor, actually the codec, I didn't provide any codec for this guy. Let's do it now. Generate the codec and let's see what did I get. So create instance group item stack dot uncounted codec dot field of stack for getter and the stack, and then apply. Okay, that's okay. Then we have the packet codec. Now this one uses a tuple of item stack dot packet codec, and I think we can use codec here. Yes, why didn't I do that? Okay, and then this is a stack, and that's the constructor. So nothing too complex actually. That codec plugin is really useful, but at some points you may want to make sure that you know what you're doing. Okay, the next one is again something a little bit more complex, not too complex, but a little bit more, and that is a stack data. Now stack data needs an integer called count and then a component changes. Now the component changes has no Java doc, and we call it components. If I open the component changes, you see that it has a codec, two packet codecs, then it has an optional of those changed components. Basically, what this class is for is to build an instance of it with component types and the values that you want, or remove the components types and make a list of the components you want to track with the changes happening in those components. And we can now make a payload from that. Do I want to keep it as a stack data or stack data payload? I think I will make it payload because we are providing some codec and packet codecs, and whenever I have a packet codec means that it can behave as a payload. The only thing that I need actually is to extend it from what I was extending before, custom payloads, and implement that method for the ID. Again, the ID is this, and this is a component stack and component changes stack payload. You don't need to be worried about these names because you won't see it regularly or normally. Then I want to have a codec, and let's take a look at this codec. We create an instance group. We want to have the integer for the count, but then we have a component changes codec, fill of the component for the getter. Nothing fancy there, it's just a normal codec development, and we have a video for that. The packet codec is again a tuple, so let me cheat and copy this guy and paste it here. It will be a registry byte buff with the stack data payload, calling it packet codec, then the tuple, and the first one is an integer that goes for the count. The second one will be component changes dot packet codec for the stack data payload, components, stack data payload components, and then we have the stack data components, new. Now this guy is count component, but the thing is that, first of all, this is the correct one and this is wrong with typos. Okay, and I will move the two to the new line. Now, I want to add few things here. Up until now, we were defining very simple packet codecs. However, this time I'm not only creating a payload, but I'm creating a record that I can utilize and use in other than being only a payload, So I will say public static stack data payload, and I will call it empty, equals to new stack data payload. The count is 1, and then it has component changes dot empty. That means that we only have one element, and that is the empty component changes. After that, we want a method. So public static that returns a stack data payload. We call it create with the number of count integers we want. We return a new stack data payload with the count that we have, and we fill everything with empty. Finally, we want an overload for this that accepts a component changes, and we call it components. And instead of component changes here, we send in the components. Now we have this record or payload as finished, and honestly the reason I was debating on using the name payload or not was that I have more functionality compared to a normal payload here, and I was debating on removing that payload name. It has its own benefits. When you don't have the payload name, it indicates to the users that they can use this record as data fields in their library or in their collection or whatever. However, they may forget that they can use this as payload, and if you put the payload name there, they will remember that they can use it as payload, but now they may think of, oh wait, how can we use it in our data collection? Anyway, remember that everything that we are providing so far can be used as data collections and data entries. However, we are using the name payload to remind you that they can be used inside network system. Finally, the last one is a string payload. Now, string payload accepts a string. The ID here is a string payload. It asks for codec string and then packet codecs of a string. And that's it. All we have to do is write these entries in our packet codec. However, I will keep that for other videos because each one of them is interesting enough and I want to talk about them as we progress forward, tell you what is going on and why it's going on. Keep in mind, some of these payloads were developed by Turtiworti, and Turtiworti is a YouTube content generator. You can search his name. He is an old member of the development community. The credit goes to him in many of these payload systems that we are writing, or even some of the classes that I develop and write in our library.
If you like these videos, please subscribe to the channel, hit the like button, and turn on that bell so that when I publish a new video, you will get informed. Have fun, everyone. Bye.